Hi everyone, welcome back to CSCI 100, lecture 17. This lecture is going to be covering algorithms, in general what is an algorithm and where they show up in the real world, and also thinking about efficiency of algorithms. And for this lecture in particular, our first lecture on efficiency, we'll think about time complexity and how we measure time complexity using timing with the time module or just counting operations. In our next lecture on algorithmic efficiency, we'll finish out talking about another method of thinking about time complexity, and we'll talk a little bit about space complexity as well. Let's get started. So, algorithms. Let's start, instead of just talking about algorithms in general, let's play a little game. Let's say it's your first time in DC. And for many of you, this is the case. It's your first time, or you haven't even moved yet to DC. And you live somewhere over here around Logan Circle. And then here we have downtown, DuPont Circle. Here is the White House, right here. So you're visiting, you're staying around Logan Circle, and you need to get to the White House. How many different paths can you think of, or can you see on here to get to the White House? So I'll give you a minute. Come up with your favorite path. What path would you take if you were staying in DC over here at Logan Circle? You had to follow the streets, and you wanted to get to the White House. So I'll show you some of mine now. I hope you have one in mind. Here's one potential path. Let's say that you tend to get disoriented easily. You're not good with your directions. And so you want to pick a path that is as simple as possible. So just one turn that you have to remember. So you start from Logan Circle, you walk all the way west, and then you walk until you hit, I believe this is 16th Street here. And you turn left on 16th and you walk straight down right to the front of the White House. So that is one possible solution. But here's another one. Maybe you don't like remembering many directions, but it's okay. You don't have to walk only on horizontal or vertical streets. You'll be okay if you're walking on a diagonal street. And you're a little pressed for time. So you want this path, this maybe was a little longer. You take a quicker path, but still the minimal amount of turns. So whatever street this is here, I forget. You walk there until you reach 16th, and you turn left on 16th and walk down to the White House. Here's another solution you might have come up with. Let's say you're always in a hurry. And so for you, no matter how many turns or twists there are, you want to take the quickest path possible. And so you follow this path down along this street. Then it looks like this is, what is that? I can't even see what street that is there. 15th Street, maybe? And then you turn right on I, then on this diagonal street, and right on H. There, you've made it. Can you think of any other paths? Well, there's also this path of maybe you're very leisurely and you want to explore the city. And so you're actually just going to take random turns and wander until you happen to make it to a point where you can see the White House. So you go up, turn right on this street, wander around, walk around, and eventually wander your way right over to the White House. So these are all different valid paths that different people would take. So, how did you come up with your path? That's my question for you. Was it one of the four that I suggested here that I came up with? Did you have a different path? How did you come up with it? This is where algorithms come in. An algorithm is the process that you use to get to an answer. So it is like this series of steps. And in particular, maybe the algorithm that I had here was at every intersection, I'm going to make a random turn. That is one possible algorithm. So for each of these paths that we just looked at, the rule that you use to decide when to turn, the rule that you use to decide is your algorithm. The path itself that you took is your solution that your algorithm came up with. And so at each intersection here, like for solution 3, what did 3 look like? So here, our algorithm was, I'm going to walk in whatever direction gets me closest to the White House. So whenever I have a choice from here, Logan Circle, we can go left, we can go right, diagonally this way, straight down, diagonally this way. This is the road that points the closest to the White House. And then from here, maybe going left or going straight down. Here it's kind of an even choice, but you decide to go down. And then you turn because this gets you closest to the White House, and then diagonally closest to the White House, and then this straight line. And here I mentioned, yes, for solution 4, your algorithm was at each intersection, I'm going to make a random turn. I'm going to walk until I see the White House.